Ladies and gentlemen, boys and girls, welcome. My name is Mr. Sepulveda, and today I'm going to be talking to you guys about what causes seasons. Okay, right here I'm going to fill in this graphic organizer. So if you want to set up your notebooks to look exactly like this, please hit the pause button now. All right, guys. So we're going to talk a little bit about what causes seasons, and there are three factors that play a role in the changing of the seasons. So we've got tilt, revolution, and sunlight energy. So let's talk about all three of these things separately, and then we'll put it all together at the end. Okay. So let's start off, and I'm going to zoom in here a little bit, and we're going to be looking specifically at this tilt box of our graphic organizer. Okay, so what do we mean by tilt? Well, when I'm talking about tilt, I'm referring to Earth, right, and how it is tilted along its axis. Okay, that red line right there on my globe, or my representation of the globe, is the Earth's axis. And what exactly is the Earth's axis? Well, it's an imaginary line that Earth rotates around. Okay, so that's what Earth's axis is. You can see that right over here in this area. Goes from the North Pole to the South Pole, connects it straight down. But notice how Earth isn't straight down this way, right? It's tilted on its axis at about 23.5 degrees, okay? 23.5 degrees is what it's tilted on, okay? So if you need to hit the pause button now to take your notes, please feel free, okay? Now, talked about the axis. We're moving into revolution, right? We're not talking about like the Revolutionary War. We're talking about revolution as in the movement of the Earth around the sun. The Earth follows along an elliptical path known as an orbit. You've probably heard of this before, right? So it's a pathway that the Earth rotates around, okay? Or sorry, revolves around. And you guys can see that clearly right here. So this is the path. I'm sorry, I'm going to make this into a lighter color. So this is the path that Earth is taking around the sun. It revolves around the sun in a counterclockwise motion, okay? So if you guys want to hit the pause button here, please feel free to do so. Okay, we talked about the tilt. We talked about revolution. Now we're going to move it into sunlight energy, right? So this one should be pretty simplistic for us, right? When we talk about sunlight energy, we're talking about light energy from the sun, and we're talking about specifically how much light energy it receives, how much light comes down to us. So when we refer to this sunlight energy, we're referring to the amount of direct sunlight. Are we receiving an intense amount of direct sunlight, or are we receiving an indirect amount of direct sunlight? Okay, so when we talk about direct sunlight, we're really referring to receiving warmer temperatures and longer days. Okay, when we talk about indirect sunlight, we're referring to cooler temperatures and longer nights. So they're pretty much opposites of each other. Now it's really easy to kind of get these guys to make a little bit more sense if we use a flashlight as a model here, right? And you guys could probably do this in the classroom if you have a flashlight and a piece of paper or a flashlight and a desk. You guys will notice that when you guys, and I'm going to zoom in here, okay? When you guys use a flashlight and directly point it down at a piece of paper or a desk, you'll see that a lot of the light concentrates into one central location. So we call that direct sunlight. And if you were to take a thermometer, put it in this location, you would realize that this area that the light is focusing on is getting warmer. Okay, if we did the same thing and angled the flashlight onto the desk or onto the piece of paper, we would notice that the light scatters and it spreads unevenly throughout. If we took a thermometer and put it in any of these areas, they're not going to be as high in temperature as the direct one, where all the direct light is hitting and focusing onto one central location. Okay, so I'm going to zoom out real quick. So if you guys need to grab your notes here for sunlight energy, please hit the pause button now. All right, guys, so we talked about these three factors, and we talked about them in an isolated fashion, right? We talked just tilt, we just talked revolution, sunlight energy, but now we're going to put it all together, okay? So in order for me to kind of explain this, or in order for us to put it together, we're going to make a diagram, okay? So this is a diagram that represents Earth in 4 different points in its revolution, right? We talked about a revolution already. Revolution meaning it's the Earth's pathway, right? Earth's pathway around this orbit, right? Going in a counterclockwise motion. Counterclockwise motion. I'm just going to kind of add the last one right here, right? Around the sun, okay? Now, when we look at this, and we can see that Earth is clearly tilted, right? We can see that this part never moves. It faces the same direction throughout. We can also notice that when we split the Earth, we already know that the Earth is split into hemispheres, right? Into a northern hemisphere and a southern hemisphere. So you can actually make that right along the axis and kind of note that this is the northern hemisphere. This is where we live versus the southern hemisphere where we don't live. Okay, it'll make a huge difference in when we talk about the season. So I'm just going to get rid of some of these extra lines real quick so I don't confuse you. Okay, and we're going to talk about the amount of direct sunlight energy. Okay, so let's look at the amount of sunlight energy that's being received here. Here in the northern hemisphere, right, this is where we live. I'm just going to shrink this down just slightly. This is what's getting a lot of direct sunlight here. So if you were to make a guess right now, which season would this be? Hit pause, think about it, and then unpause to find out the answer. If you guys said summer, then you are correct. When this northern hemisphere is tilted towards the sun, we are experiencing summer, which means we're going to experience longer days and warmer temperatures. Okay, now let's look at this opposite side, right all the way across here. The northern hemisphere is on this end, right? Sorry, the northern hemisphere is right over here on this side, right over here, okay, on the left side. Now, what happens here is that now the southern hemisphere is receiving most of the direct sunlight, right? So what season would the southern hemisphere be in? Hit pause, think about it, and then unpause to find out the answer. If you said summer, then you're correct. But how can these two be summer? Well, it all depends on the amount of direct sunlight. Notice here on the very top of this diagram, and I'm just going to change my color here real quick, right? We talked about this spot being summer, but we also talked about this being summer. But notice how the hemisphere is a little bit different. What season would we be experiencing if our northern hemisphere is tilted away from the sun? Well, if you thought winter, then you were correct. So we're experiencing winter right over here when our northern hemisphere is tilted away from the sun, okay? So that means since we're getting a lot of indirect sunlight, that means we're going to have longer nights and we're going to have cooler temperatures in the north. Whereas because the southern hemisphere is receiving direct sunlight, they have longer days and they receive warmer temperatures here. So that means when we're in summer, the southern hemisphere is experiencing winter. When the southern hemisphere is in summer, we're experiencing winter. Okay? Not too bad, right? And then over here, you guys will notice that we have autumn or fall and we have spring. Now this is when both sides, right, both hemispheres end up receiving equal amounts of sunlight, which for us means that we're going to have equal amount of days and equal amount of nights, and we're going to have moderate temperatures. They're not going to be too hot or too cold. Now, I have one more thing I want to show you to kind of sum up this diagram really quickly, and it's this chart right here. Okay, it talks about the different continents, different locations on the globe, and different months and what kind of seasons are being experienced. So North America, during June, July, and August, you guys love these times because it's summer, right? You guys aren't in school. And then autumn hits during September, October, November, winter, December, January, February, and then, of course, spring, March, April, May. Now, let's look at this from another perspective. Let's look at this from another place on the globe, specifically the southern hemisphere. So I want you guys to kind of remember, right, where we're at. So in July, June, August, we experience summer. But if we were in Australia, right? If we're in like southern Australia, southern months are December, January, and February. Isn't that interesting? Because December, January, and February are our winter months, right? Now, our winter months are December, January, and February again. But during their winter months are our summer months, June, July, and August, right? So what does this tell us? Well, this tells us a lot about this diagram that we just created. So whatever the northern hemisphere is experiencing, the southern hemisphere is experiencing the opposite season. Ladies and gentlemen, thank you so much for staying tuned. Now it's time for you to follow the rest of your teacher's instructions for the rest of class. Bye-bye.